113, we're going to prove the supplement theorem. First of all, what does the supplement theorem say? And I'll write it down.
It says, if two angles form a linear pair, then they are supplementary angles.
Then they are supplementary.
Yes. Angles.
There's the theorem. Okay, eyes up here. What I have to basically do is create a situation that does that. Okay, so draw a linear pair. Isn't that a linear pair? By definition, aren't a linear pair two angles that together form a straight line, 180 degrees? So call that angle 1, angle 2. So what's given to us? Angle 1 and angle 2 form a linear pair. I want to prove that angle 1 and angle 2 are what?
Supplementary.
One. That's given. Angle 1 and angle 2 are a linear pair. What does that tell you that they're a linear pair?
They're two different angles in one district.
Tells you that they're adjacent and that they add to what?
180.
Two adjacent angles that add to 180. So the measure of angle 1 plus the measure of angle 2 is equal to what?
180.
Definition of a linear pair? Isn't that also what the definition of being supplementary means?
Yes.
So angle 1 and angle 2 are what?
Supplementary.
In essence, I think that's about all you need there. There's really not a whole lot more to that.
What number did you say that was?
16, wasn't it? What's 17? What theorem are they asking us to prove there?
Complement theorem.
Okay. What about the next one they asked us to prove? That's about along the same lines.
Reflexive property of congruency.
Okay. Let's do that one. What does that property say? If what? What does the reflexive property say of angle congruency in the book?
It says, let's see. Well,
Angle 1 is congruent to angle 1. Saying reflexive property of congruency, right?
Right. I mean, think about that one. So what would be your, I guess your given would just be angle 1. That there exists an angle one, and your proof would be what? That angle one is what? Congruent to angle one, right?
Yes.
Is there an if-then statement that goes with that in the book? Taylor, is there an if-then statement that goes with that in the book?
No.
Just as angle one's congruent to angle one, right?
Yes.
Okay. Let's say the measure of angle one, how about we say how as a given, we say the measure of angle one is equal to 30, okay? Let's just pick up, okay? Everybody okay with that? So, measure of angle one equals 30. Why is that true? Given. 2. The measure of angle one is equal to what? The measure of angle one. Does anybody know how I was able to do that?
Definition of.
Symmetric
Definition of-
property.
Is it
It's
definition
okay.
of anything?
Yeah, I didn't expect you to. Didn't I just, when I say measure of angle one equals 30, right? I'm saying wherever I see a measure of angle one, I could put what? Or wherever I see 30, I could put what?
Measure of angle one.
So what did I do?
Substitution.
I substituted measure of angle one for what? 30. Didn't I? Now what can I say? Angle one is congruent to what?
Angle one.
Definition of congruency. Trust me, some of the later theorems you have later on are much harder to prove than these, but these are so obvious it's sometimes hard. Probably now that I think about this, probably the right way to do this is to say the measure of angle one is x. Because then it's any number, right? Agreed? So I'm stating that no matter what the measure of x is, measure of angle one's always going to equal x, so I can substitute it in so that everything's going to be equal to itself. But for all intents and purposes, the 30's fine too. But that probably would have been the better way to do that. Okay? Because every angle has a measure, correct?
Can we go up to the